Hey there, Genetics 311. My name is Jack Wild. This is my exam mini video 3, and I'm going to be talking to you about Hardy-Weinberg equilibrium and how selection actually violates it. Before we get into any of the big numbers or ratios when it comes to Hardy-Weinberg equilibrium, you need to know the 5 rules that a population has to meet in order to represent this equilibrium. Number 1, no mutations. Number 2, random mating. Number 3, no gene flow. Number 4, a large population size. And number 5, no natural selection. So, what I'm going to do now is put us in a fictitious test environment. We're going to be focused on an island that's isolated, and on the island is a population of 500 snakes. There's going to be 3 different genotypes and phenotypes talking about the color of the snakes. I'm going to show you the numbers and the different ratios that actually represent Hardy-Weinberg equilibrium. Looking at our island, you can see the 3 different phenotypes, the 3 different genotypes, the number of each, and their ratios. If you plug them into the equations below, you can see where I calculated the P and Q frequencies. So that's the frequencies of the dominant and recessive allele. And no matter where you plug in those frequencies, whether it's the top equation or the bottom, you will come out with a 1, showing that this population does indeed represent Hardy-Weinberg equilibrium. To introduce directional selection into our environment, a fire is going to take place on this island, and it's going to destroy most of the vegetation and alter the land significantly to the point where green and brown will now have a significantly less impactive camouflage, and the black will be able to blend in with the ash and destroyed vegetation a lot better, making their fitness a lot higher than the other 2 phenotypes. Here are the numbers reflected. So, for the 3rd row, we have the proportion of survivors, where we multiply the initial frequencies and the fitness of each genotype, resulting in the numbers below. And on top of that, we take those numbers that we've now acquired to get the weighted average, which turns out to be 0.728. We then take those proportion of survivors and divide them by the new weighted average, because it needs to be represented as out of 1, and you will get the new frequencies below in the final row. And this shows the directional selection of the black phenotype. So, what does this all mean? This means that the type of natural selection was directional. You can see this in the different ratios, specifically the black one increasing and the other 2 decreasing. And what this means is, as new generations keep going forward, most likely the black will continue to increase for the next couple generations until another either predator enters or another natural disaster happens, or maybe the island recovers. For now, the black phenotype is the most fit and will continue to increase in frequency because of their new increased fitness. That's all for this mini video. Thanks for watching.